everyone and welcome back to another new video of Basics of Electrical and Electronics Engineering, which is a subject for first year KTU syllabus students. So in today's video we are going to discuss what is the average value, RMS value, peak factor, form factor of a full wave rectified AC voltage waveform. So here also it is a standard waveform where you won't be given any waveform in the question paper. You have to draw it by yourself. So what is a full wave rectified AC waveform? How will it be looking? The negative half cycle also will be rectified into DC and your waveform will be looking like this. See, the negative half cycle is also rectified and this becomes a DC waveform now. Okay, let us consider what is the average value of this waveform. So average value is equal to area under the curve for one cycle divided by time period for one cycle. So where is one cycle here? What is one cycle here? Here you can see the waveform. Either you can consider the positive and negative half cycles, but here there is no negative half cycle. So we have to check where the waveform is being repeated. Here you can see from 0 till pi. Then again it is being repeated from pi to 2 pi and going like this. So the repetition occurs at pi, or one cycle is from 0 till pi. Hope it is clear for everyone. So let us consider what is the area from 0 to pi only. Why? Because the time for one cycle is only till pi. So we have to find only till the area till pi only. Now again here this is a sine wave. So we don't know how to find the area under this curve. We have to use the integration method. So please go through the previous videos to study in detail how to calculate the area under the sinusoidal curve. So here also we can write integral 0 to pi v d theta by pi. Now we are going to substitute, instead of v, we are going to substitute as Vm sin theta d theta. Okay, divided by what is Vm by pi, integral 0 to pi, Vm by pi is a constant, taking it outside, and the remaining terms are 0 to pi sin theta d theta. Integral of sin theta is minus cos theta in the interval 0 to pi. So Vm by pi in the intervals minus cos pi minus cos 0. Then next one is Vm by pi. We are substituting the limits, the values. Cos pi is minus 1 and cos 0 is 1. So substituting all these values, you are getting as 2 Vm by pi. Okay, 2 Vm by pi. So this is the average value of a full wave rectified AC voltage waveform. Next we are going to find what is the RMS value, for which we are going to use the equation root of area under the squared wave for one cycle divided by time period for one cycle. So what we have to do first, we have to draw the squared waveform first. So here you can see this is our original one. We are going to square it. So your squared waveform look like this. Now we are going to find again the area from where to where? From 0 to pi. Why? Because here also the cycle is from 0 till pi. What is the area of the small strip? Area of the small strip is v square into d theta. So area of the small strip we have to integrate from 0 till pi. So integral 0 to pi v square d theta. Integral 0 to pi, instead of v we are going to substitute as Vm sin theta, Vm square sin square theta d theta whole divided by pi. Okay, now Vm square by pi is a constant, we can take it outside. Integral 0 to pi 1 minus cos 2 theta by 2. From where did we get this equation? Yes, Vm square sin square theta, instead of sin square theta we are substituting as Vm square has been taken outside. So sin square theta is written as 1 minus cos 2 theta by 2. Now integrating this one we are getting as theta minus sin 2 pi divided by 2. Why? Because 1 when we are integrating you will be getting as theta. Cos 2 theta becomes sin 2 theta by 2. So Vm square divided by 2 pi into 2 has been taken outside. Okay. Now we will be getting the expression like this. Vm square by 2 pi, putting the limits you will be getting the expression like this. And here also pi only is remaining. Pi gets cancelled and the last answer becomes Vm by root 2. From which you can find out what is the peak factor and form factor. Peak factor is equal to peak value divided by the RMS value, and peak value is Vm, RMS value is Vm by root 2. You will be getting the answer as 1.414. Next one is a form factor. Form factor is equal to RMS value divided by the average value. RMS value is Vm by root 2. Average value is 2 Vm by pi, and the answer is 1.11. I hope it is clear for everyone. Please, before going through this video, you should cover the previous two videos before going into this video. Why? Because there I have given you a detailed explanation of how to find the area under a sine curve. How you have to find the area under a sinusoidal curve. Okay. Thank you everyone for listening. Stay tuned. Bye.